Good morning, students. Our today's topic in the subject of Mathematics 3 A levels is trigonometry. And in trigonometry, today we are going to study some concepts of the double angles. So concentrate yourself now. So sine 2x is 2 sine x cos x, cos 2x is cos square x minus sine square x, and other formula of the cos 2x is 2 cos square x minus 1, and another formula is 1 minus 2 sine square x. So these are three formulas of the cos 2x. Now tan 2x, the formula is 2 tan x over 1 minus tan square x. So these are a double angle formulas which we are going to use into the question now. So you have to understand and learn these formulas first, and now we are going to solve. Here is a question: if sine x is equal to 8 by 17, where x is acute, evaluate sine 2x, tan 2x and cos 2x. So first we have to apply the Pythagoras theorem to find the remaining things. So look now, here is a right angle triangle. Sine theta is perpendicular over hypotenuse, so it will be 8 will be perpendicular and hypotenuse will be 17. So this base is missing. So applying Pythagoras theorem, that is hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 17. So 17 square is equal to perpendicular 8 square plus base x square. From here, solving it, 17 square minus 8 square will be equal to 225. So x square is equal to 225, and taking its square root is giving us 15. So it means x is 15. So this side is 15 now. So now we can find cos x, that will be base over hypotenuse, means 15 by 17, and tan x. Tan is perpendicular over perpendicular over base, so 8 by 15. So now we are able to proceed further. So first part is sine 2x. So here is first part, sine 2x is the requirement, that is equal to 2 sine x cos x. Applying values here. So sine x is 8 by 17 and cos x is 15 by 17. So solving here, so 16 into 15 is equal to 240 over 17 square is 289. So this is the answer of first part. So look now, second part is tan 2x. So tan 2x, that is equal to 2 tan x over 1 minus tan square x. So putting values into the formula, tan x is 8 by 15. So 2 into 8 by 15 over 1 minus 8 by 15 whole square. So solving it now, in numerator 16 by 15, in denominator taking LCM, so 2 to 5 minus 64 over 15 square. Okay, 2 to 5 minus 64 will be equal to 161. In numerator, we are having the same thing, that is 16 by 15. Now this fraction is going to the numerator, so 15 square will come into the numerator, and 2 to 5 minus 64, that is equal to 169, will come into the denominator. So 115 will be cancelled here. So 16 into 15, 240 over 161. So this is improper fraction. So solve it now. 240 over 161. That is 1.49. So 1.49 is the answer of this part. Okay, now come to the third part. That is cos 2x. So cos 2x. Okay, now we have all values, that is sin x, cos x, and tan x. Whatever the formula, actually they cos 2x is having three formulas, so we may use any of the formula. So I'm applying the first formula. So cos square x minus sin square x. Now cos x is 15 by 17. So 15 by 17 square minus sin x is 8 by 17. So 8 by 17 square. Okay, taking LCM, in the denominator we have 17 square, that is equal to 289. So same values in the denominator. So in the numerator, simple things will be subtracted, like 15 square is 225 minus 64. 225 minus 64 is 161. So 161 over 289 is the answer. Here is another question. The statement is solve sin x plus 2 cos 2x plus 1 equal to 0 for this range x greater than 0 and lesser than 360. So look now, two different trigonometrical ratios are there. So first we have to convert them into single one by using the formula of cos 2x, this one, because then all the trigonometrical ratios will come into the sign. So look now, here is the solution. So sin x plus 2 and cos 2x formula is 1 minus 2 sin square x plus 1 equal to 0 will remain as it is. From here, open the bracket. So sin x plus 2 minus 4 sin square x plus 1 equal to 0 is still there. So further is minus 4 sin square x plus sin x, okay, plus 2 plus 1 is plus 3 equal to 0 is still there. Taking minus sign and go to the right side, so the thing will become now 4 sin square x minus sin x minus 3 equal to 0. So this is a quadratic equation now. Multiply the coefficient of the first one with the last one, 12, and central coefficient is 1. So we have to think a pair of the numbers whose multiplication equal to 12, addition or subtraction equal to 1. So actually these are 4 and 3. This sign is telling us that opposite sign will come, and this sign is telling us that bigger will have minus sign and smaller will have positive sign, and sin x will be written with these two numbers, and we will place this factor in place of this one. So this was rough work. So proceeding further from this step, 4 sin square x minus 4 sin x plus 3 sin x Minus 3 equal to 0 will remain as it is. Okay, making pairs, take common. In first pair, 4 is common. Remainder is sin x. Okay, 4 sin x is common. Remainder is sin x minus 1. In second pair, plus 3 is common. And remainder is sin x minus 1 equal to 0 is still there. The bracket which is same will be written once, and the values outside the bracket will be written in the second bracket. Equal to 0 is still there. From here, sin x minus 1 will be equal to 0, and 4 sin x plus 3 equal to 0. From here, sin x will be equal to 1, and from here sin x will be equal to minus 3 by 4. Okay, from here basic angle will be sine inverse 1 and sine 0 0, sine 91. So alpha is, so from here we are going to find the angles. So sine inverse 1, that is 90 degree. Okay, that is actually 1. So this is 90 degree. Okay, from here sine is negative. So sine is negative, all students take chemistry. So third and fourth quadrant is there. These are the basic angles, and the basic angle will be alpha is equal to sine inverse 3 by 4. So sine inverse 3 by 4, that is 48.6. And from here the original angle x will be equal to 180 plus alpha. Okay, the range is given in degree mod. Okay, the angle will be 180 plus alpha and 360 minus alpha. So plus 180 is 228.60, and 360 minus 48.6, 311.4. So these are the answers: this angle, and this angle.